autonomous sensors. Well, one of the nice things that I feel is maybe at the forefront of people's brains right now is that the more time you spend on the road, the more chances there are for an accident. So you can get gains in your health and safety and environment, less site trips. And my understanding is that it's hard to find, there's not as many folks to fill these roles as are needed right now. So it kind of limits the amount of sites you can cover. So it'd be nice if, say particularly remote sites too, if those could be automated, we're reporting there and we can have our staff go and do the manual sampling on sites that might be a little bit closer and easier so they can get a little more bang for their buck. So it can help lower costs and also triage sites. And then the sooner the data come in, the sooner you can make decisions on whether it's how effective a remediation treatment is, or you're gauging seasonal effects on the plume. And also, some of these gases are very episodic. So in particular for natural source zone depletion, you want to count for gaseous ebullition, which is, you could say that and get uninvited real fast to a lot of parties. But the reason why that's important is because, getting back to methane, there's these processes that are going on as hydrocarbons are breaking down, mainly fermentation, where it's anaerobic, and you get these periodic releases of bubbles. So you can have, a lot of activity, you get a release of methane, and then it kind of stagnates for a while because there's the activity from the microbes, and there's also just the physicality of those bubbles escaping from the water to be detected by a sensor. So if you're measuring in real time, you're catching all these events, and so you can get a more accurate picture of how depletion is proceeding. And this picture here, just as an aside, is actually ChatGPT's interpretation of gaseous ebullition. So it's not actually any scientific rigor. It's just a nice representation of, okay, we got these bubbles that are making their way to the surface. And there's a lot more, maybe some aliens in there too. And the one thing that resonates with me about having autonomous sensors is that you can capture trends a little bit sooner, a little bit more robustly. So for instance, here we've got November, it's a fall sampling, say there was 3 wells that got sampled. Okay, great, we got this distribution. When you compare those to what the data are doing over time, you're really just getting a small snapshot of like, okay, this is how this site could be doing at this particular day of the year. So sorry if anybody's colorblind, but the green dot, you might have some robustness there. It's okay, this is indicative of what's happening at this location over time. But those other two might not be as robust. And so you might not paint the most accurate picture of what's going on at a site. With this next figure, this is where we've gone one step further and interpolated a plume using those sensors. And so it's plume area on the Y, and it's time on the X, and then you can see the plume fluctuating through time. Now, if we do a thought exercise here, where let's say that we do 2 fall samplings, we get these 2 points in time. You might interpret those data as, oh, our plume is growing, this is a problem. Or a more rosy picture, you got a fall and a spring sampling, it's like, oh, it's shrinking and it's going away quickly, this is great, we can get this off our books next year. When in reality, it's a little bit more of a more nuanced picture, that if you look at the overall trend, yeah, there's some seasonal variability, it goes up and down, but overall it's shrinking, but not quite as much as that latter example might suggest.